Hello and welcome back. Today, March 17th, 2024, we're going to be diving into FTT122, Introduction to Ammunition and Ballistics. Basic ballistics, yes. This will be a three-part. With the first one, articulate your current superficial understanding of the 4 steps of ballistic: internal, transitional, external, and terminal. Starting with internal, well, we're also going to go over variables with it. Might as well merge them into one. Internal, which is basically the internals of the cartridge mated with the round. Different variables you can have with that. Really, the only thing I really found on that one that was a bigger one was the amount of grains inside the cartridge, right? When you cause the spark, basically. The next one is transitional. From the time that the round exits the cartridge after firing to the end of the barrel, the process in which in there. One of the variables in that, how many grooves basically the barrel causes the round to turn. That's a bigger one. The length of the barrel, obviously. After that, you have external. External is when it leaves the end of the barrel, the muzzle, and it's on the way to the target. Those are your external ballistics. So many different variables with that. Wind, depending on how far you're shooting. Gravity, is it raining, snowing? Yeah, a whole bunch of stuff. Altitude could be one, because there's less air the higher up you are. Gravity could be another one, depending on how far you're shooting. After that is terminal ballistics, hitting the target, whether that be steel plate, paper targets, dirt, gelatin for research purposes. And those are the 4 steps of ballistics, and a couple of variables that can affect flight and performance. Part 2, describe what sectional density is in a way that a person who is unfamiliar with ballistics could fully understand the concept. I'm not gonna lie, I had no idea what this was when I first started, when I read the question. Put the official textbook term out there. Sectional density is a ratio of a projectile's mass to its diameter. The higher the SD number, the greater a projectile's mass in relation to its diameter. Basically, it's covering mass and diameter. And the only purpose for this, and why you need to know, or why you would want to know what the sectional density of a projectile is, penetration. Yep, that's basically it. Layman's terms, how well does it penetrate? And there's a whole formula for it. Recommend you look it up, see what your rounds are at and which one would be the best. Really aids to the argument of which round's better. Part 3, got to choose from a following of questions. A lot of them felt like the same, but different for most of them. So, because I didn't know a whole lot about sectional density, I decided to go with, why is sectional density considered to be more important than projectile shape? With that formula, looking up a couple examples, doing a little bit of research, stuff like that. Scroll down here, get a little bit better of an idea of what I'm looking at. Just going over the numbers and stuff and seeing like the difference. It doesn't matter what your round is shaped like. A lot more of it goes into, when we go back to the penetration, right? Sorry. Going back to the penetration part. More important than projectile shape. So obviously when you get into certain rounds, they're going to be really similar, grains, stopping power, so on and so forth. But penetration, when talking about sectional density, can also be penetration through the Earth's atmosphere. How it's another factor for distance and this and this and that. It really doesn't matter what your round is shaped like if it can't get to its target. You're not going to put a 9mm against a 5.56 when you're trying to hit a target that's far away. because it's not going to get there, aside from being the way it's shaped due to the low sectional density.